All right. So here we go. Oh, here's our calendar, and I have it updated. All right. Okay. So from our glorious three. Oh, let me go back to that calendar for the bums that are not here today. Okay, fine. Absences happen, some more than others. Um, but it's right here. You should watch these three videos to understand what a radian is. All right. Radian. Okay, and then here it is, and I'm only going to draw one of them on this, and then you get this. So here is the radius, one radius of length. Obviously, that's one radius, which just seems weird. I just don't want to put a number there. I don't want to be stuck to a number. Then when you go to the circle, and this is approximately about one radius in length. Well, then that was the definition of what a radian is. I'm going to change this color. When I draw this second side here, this angular displacement is therefore called 1 radian. And then from the videos, you notice 2, 3, 4, 5, up to 6 radians get you in quadrant 4. And then hide. And then that should be totally understood. So I should be able to move on. Many days I did not show that video, and I tried to explain to students this, and it didn't go very well. I felt like those videos are very, very, very informative and helpful. And then this is 100% related to circumference, which was in the third video. How does one rotation equal 2 pi radians? Well, it's because a radian measure, theta, is found by arc length, which is how far you walk around the circle, divided by the radius. I better fill these all the way out because rad could mean radius or radian. That's literally what I did right here. I took one radius worth of length on the arc length divided by the length of the radius, and I got the number 1. All right. When I kept going and I went to here, that was 2 radians because this was another radius length equal to this one. So that's 2 radians when I draw that side and so on. That's all in that other videos. The first video does a perfect job of showing that. So when I take the full circle, 2 pi r, and divide it by r, hence I get 2 pi radians. And that is equal to, as the video showed, 360 degrees. So something else you should mark is pi radians, therefore, is half of that, which is 180 degrees. So be familiar with these two things, and everything else falls into place. And then in that one video, the second one, where it started the second one where it started with 57.29 degrees as 1 radian. Where did he get that from? He divided by pi, right? And then that is what 1 radian is equal to, which was equal to that 57.29 degrees-ish. You don't need to know that. I want to reference why that guy said that and did that. So blah, 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 blah. So what's 1 degree? Take the other side and divide by 180. By the way, that symbol degree is just laziness by a mathematician to not have to write the word degree. All right. So when I divide by 180, then I get pi over 180 for 1 degree. All right. And that's what that equals in terms of radians. So that's where we get this. And then that's what you're going to have to memorize to in order to convert. Okay, now, dimensional analysis. You don't have this on your paper. This I do because A, we are going to have to do this later in the chapter anyway. And I'll inform you about the chapter. This shouldn't take too long. There are 2 parts. There's unit circle trig again, and then there's 2 sections that have nothing to do with trigonometry at all. They are radian applications that are non-trig related. You have a quiz this Tuesday. It's all the unit circle doing trigonometry stuff, and that's what we're going to stick with to begin with. Okay, and then after that, we'll do the applications. I just have a random question out there that says 7 feet per second. Okay, so how does a scientist and you guys expected from a science teacher convert 7 feet per second into miles per hour? hopefully they teach you to do this. Write it as a obnoxious fraction. And then you do your conversions. Why am I doing this? Because of our conversions from radians to degrees and degrees to radians. It essentially is dimensional analysis. And another thing, you are literally going to have to do dimensional analysis in the later sections in this chapter. So this is coming up. So first of all, how many seconds are there in a minute? Say it. 3, 2, 1, go. 60. Let me do the units second, the time in green. Where do seconds go? In the top or the bottom, you dimensional analysis people? 3, 2, 1, go. Top. Why? So the word cancels. I never understood how students don't understand this. It actually is pretty simplistic. And here's another thing. This fraction equals what number actually? Ooh, that's tough. What does that actually equal? Starts with a 1. I know you're going to say it equals 60, Mr. Samuelis. No, these are equal. They're just in different labels, but they are literally 100% equal. So that fraction equals 1. You are literally multiplying this by a form of 1. So you're not changing its value. But why do seconds have to be on top? So they cancel. All right, now I'm covering this slow because not enough students know how to do this in the history of me teaching CAT. This doesn't go well. All right, and then how many minutes are in an hour? And where do minutes go? Well, you should know it goes up here. And then this is 1 hour. And that is equal to 1. And now I get to cancel those minutes, cross canceling. And then, the magic question. How many feet are there in a mile? 3, 2, 1, go. Oh, last hour sprouted out right away. How many feet are in a mile? 5,280. You better get that memorized because you're kind of supposed to have that memorized. It's kind of expected of you. Why did I put it on the bottom? So what? Feet cancel. And then this tells me numerically what do I have to do. And then, by the way, I like doing this at the end. Miles per hour. Yes. So I have miles over hours. Miles per hour means fractional. And then I just have to multiply by 60, and then divide that answer by 5280, and I'll have my answer. Okay, so why did I go through that? I don't think I'm doing all of these. You know what? Let's skip to this one first. Let's skip to degrees. So I know you might flip your paper back over and say, wait, which one is it? It should be easy. Where should the 180 be? The 180 degrees on the top or the bottom? Where should the 180 degrees be? Where should the degrees be? On the bottom. So this should be on the bottom so that the word degrees cancels. That's why I went through that dimensional analysis stuff. All right, so all of these are multiplied by pi over 180. And I'm not going to do them all. You can use your calculator possibly. We're really going to hit this unit circle down here and talk about that one. I'll do this first one, though. 88 over 18, the zeros cancel, and then 2 goes into both. 4 over 9 pi radians. And then you could do the other two. I'm moving on. Okay, and then back up here, obviously you're going to say then, what do I multiply by for this one? 180 over pi or pi over 180? Which one is it? It's the reverse. But the real reason is the word radians is up here. So, whoa, that's a 180. The word radians must disappear. Or usually radians have pi in it when they give it to you. So what else has to cancel? The pies. Now the third one is the worst. Okay, but that's okay. And I'm going to do all three of these because the radians might need a little bit more work. 5 in the 180. Oof. 10 in the 180 is 18. So 36. And then 9 times 36, 918, 270. I didn't do too well on this because no one's going to help me on the calculator anyway. 300. Somebody help me with the calculator. I'm going to cry. I'm touched. The next one. I know what the answer is. Anyone in Math 3 honors? No, you know it already then. Math 2 honors 2 years ago. You should already know what that is. An over 2. I know 2 years ago I did radians with the students. So 180 over pi. So the pi's can cancel. 2 into 180 is 90. 3 90s is negative 270. I was hoping those that were in Math 3 honors or Math 2 honors remember an over 2 in radians ends up on a y-axis, either 90 or 270. And that's coming up for everybody. And then 1 and 1/4 negative, just make that negative 5/4. Multiply that by 180 over pi. There is no pi to cancel. So basically, you go to your calculator and then get a decimal for this. You did not lose pi, so you do have to divide by pi. All right. And then how do you type this on your calculator? You might put parentheses here and parentheses here. Negative 5 times 180. Put that in parentheses, divided by parentheses 4 times pi. That divides both the 4 and the pi. But the pi doesn't cancel, so that's part of still the calculation. Okay, now going to this. This literally is what you have to do in number 83 in your homework. And any charlatan that does not do number 83, you already put yourself in major disadvantage the rest of this chapter. This is why I say not doing homework does not work in this class. I know that's a double negative. But I'm going to do a couple, and this is what they expect you to do. Like this is 0 radians. And then what is this in degrees? We'll keep radians in red. What did I say a full rotation is in radians? What is this also then? 2 pi. And then I'll go blue for degrees. What is this in degrees, a full rotation? 360. Now I'm going to fill a couple in, and I'll tell you what number 83 looks like. They give you some, and then you have to convert to some others, and I'll do a couple of them. But I am going to do this. Half a rotation is 180 degrees. What's half of 2 pi in radians? 1 pi. So everyone get familiar that 1 pi is half a rotation. Now, number 83, they may give you 180 and they may ask you to convert it to radians. And then you'll see that this happens. This is how they do it. They have one or the other given. You have to convert them. I'll show you, but I'm doing a few here. In radians, this is pi over 2. How did I get that? I literally just took half of that. Half of pi is pi over 2. Half of 180 is 90. We also know that this is 90 degrees. So I'm trying to keep the degrees in blue and the radians in red, because this is what you're going to have to get really good with. What do radian measures look like when they are a particular type of angle measure in degrees? All right. And kind of wanted to be cryptic about that. By the way, listen, 1 pi over 2, 2 pi over 2. Think about that for a minute. What happens to the 2's? 2 pi over 2. What happens to the 2's? Cancel. So what's next? 3 pi over 2. That's why I knew 3 pi over 2 negative was equal to negative 270. But now it's positive, so I keep them positive there. That's why I knew negative 3 pi over 2 is going to be negative 270 degrees. Okay, now let's actually do what the book does. They give you, what am I in? Blue. They give you 30 degrees. And then they say, fill in this blank. Well, then this is what you're expected to do on number 83. I'm going to do one from each quadrant. You're supposed to take 30 degrees off to the side and multiply. I should have asked you, but it's 1 pi over 180. Why? So who cancels? Starts with a D. The degrees. And then this one's pretty easy. Bang, bang. These cancel. And then 3 goes into 18 6 times. Oh, I'm supposed to be in red. So this is pi over 6. I'm going to do one more of these, and then the Math 2 honors and the Math 3 honors will remember this, or already do. I'm going to go over to this angle measure right here, and then this is given. 5 pi over 6, and they want you to find the degree measure. So then what you have to do off to the side is, okay, 5 pi over 6. I multiply that by, well, this is easy. The pi's have to cancel. So I have to multiply by 180 over pi. Cancel, cancel. 6 goes into 18 3 times. So 180 30 times. 5 30s is 150. By the way, what kind of triangle does 150 make? A 30, 60, 90. And notice I just did 2 over 6s, and both of them make a 30, 60, 90. This is an always. Always, when you have a radian measure where the denominator is a 6, when it's fully reduced, you will have a 30, 60, 90. You just got to figure out what quadrant you're in. Let's do another one. Let's say, like, what did I do the last one? An angle measure in degrees. So let's do a radian measure. I happen to know these. I've done this quite a while. So 5 pi over 4 happened to land right here. So they want you to fill in what is the missing degree measure. And I'm trying to color code the degrees in blue. So here's 5 pi over 4. I convert that, and the pi's cancel. 2 goes into 180 90 times, so half of that is 45. Notice that. Notice that's a 45. 5 45s is 225. So guess what you can say in always? 45s always end up being what's? Over what's? 4s. You're going to see that when you do in your 80, you do number 83. I think it is number 83. Then the last one, we should know that this is 300 degrees. So you have to find the radian measure. Okay, so I got to take 300 degrees and do the flip, pi over 180, so that the degrees can cancel. The 0 cancels. And then 30 and 18 have 6 in common. 6 goes into 35 times. 6 goes into 18 3 times. Guess what an always is? A 60-degree reference angle is always an over what, everybody? 3. The quicker you get that figured out, the quicker you're going to get really good with chapter 3. All right. Now I'm done with that. I'll do these last ones for the purpose of the video. Now it's trig of these. Okay. And then this is what we're really going to work on tomorrow. All right. Tomorrow is really hammering down the trig of radian measures. I don't know if I have a worksheet or not. I forget what I do. I think I kind of like a worksheet for this. We already did this one. What did I just say 5 pi over 6 lands at? I shouldn't have done that. Where does it land? What's the degree measure that it corresponds? So here's where 5 pi, here's what you're eventually going to have to do, though. Well, I'll wait on that. I'll wait. I don't want to get too fast with this. We just literally converted this. We just literally knew that 5 pi over 6 is equivalent to 150 degrees as an angle measure move. So what's this reference angle right here? What is it? 3, 2, 1, go. 30. And then I got to make decisions. The other math teachers are doing something different on memorization. I'm a triangle guy. What's this side measure? Because then you only have to remember one thing. And then what's this side measure here? It is negative root 3. And then what's this side measure? 2. And now I can do sine. What sine? What letter over what letter? So what's the answer? 1 over 2. So again, we've just found trig of a radian measure already. We've already found it because we know it converts to a degree measure, and then it's a chapter 2 question. It's actually repeating chapter 2 all over again. That's why chapter 2 is a backbone. It really is the backbone, and this is the backbone of the rest of the year. We don't get this stuff done, we're done. We're doomed. Hey, anyone have a, let's all say this together. It very possibly could be wrong because it's too early, but where does 7 pi over 4 land? What quadrant? 1, 2, 3, or 4? 3, 2, 1, go. It's actually 4. You want to know why? This is what you're really going to have to get good with. You know what 8 pi over 4 equals? What does 8 pi over 4 equal? 2 pi. So you're literally pi over 4 short of 8 pi over 4. That lands you in this quadrant here. This is where 7 pi over 4 lands. I try to teach this. Both my girls are doing this at this point. Wait, Sammy, I don't think is doing trig yet. Brianna's thick into it. She's actually way past us now. I worked with her in this in September, October. But anyway, okay, fine. I'm not ready for that. Take 7 pi over 4, multiply by 180 over pi, and then tonight is the last time that you do this. You're going to have to know that an over 4 is a 45, and it is 7 pi over 4 in quadrant 4 by what I just showed you over there. But go ahead and cancel, and then not to bore you on this, there you go. That's 45 again. 745s is 315 degrees, which is 45 degrees short of a full rotation. So this triangle is 45, 45, 90. Sides are 1, 1. What's the last side? Square root of 2. You guys actually, you ready for a compliment? Overall, we are better than students of the past. I got everyone that, almost everyone's there. The only people making mistakes are saying 1, 1, and 2. That's not right. 1, 1, and 2 is not right. And some people on the 30, 60, 90s are putting 2 here and root 3 there or something like that. Nope. Biggest side is the hypotenuse. So those that are doing that, get that out of your system. But anyway, what's cosine? Oh, by the way, who's negative? One right or one down? One down. And then this is y, x, y. Almost done. Doing awesome. So what's the cosine? So it's square root of 2 over 2. Someone already said it. You already know the rationalization. You know you're dealing with the same thing from chapter 2. These ratios keep coming up over and over and over again. I don't think I did 2 pi over 3. What quadrant does 2 pi over 3 land in? This will be interesting. 3, 2, 1, go. It is 2. You know why? Because here's 3 pi over 3. This is how we're going to do this later. I know this is throwing stuff out you, but radians are fractions. If you have any fractional understanding at all, you'll know where these land. So 2 pi over 3 going this way is short of 3 pi over 3. And then I think I said this already. What's an over 3? A 30 or a 60 reference angle. 60. Actually, 2 pi over 3 is equal to 120 degrees if you did a conversion. So that is why this is 60, and this is what's coming. By the way, if you get this down, this is what kills people. This is why people get D's and F's. They just can't do chapter 2 and chapter 3. People that can get this and already feel good about this, you have a really good chance for an A or and a B the rest of the semester. All right? Really, really, really. Negative, positive. Tangent is y over x, which is negative root 3. Okay, drop it like it's hot. That wasn't very dramatic because I can't get this turned off fast.